So in about 1 minute, the Advent of Code 2023 problems are going to be released. Essentially, it's just a bunch of varied problems. I'm going to be doing them in C++, Microsoft's compiler, MSVC, in the latest possible version. So if you try to copy this down, half of it probably isn't going to work. I'm going to include some libraries inside of here that we'll probably need. You never know. Do that. Okay, that's probably my setup. Actually, you know what? Let's do some input, do some output. And that's what we got. Okay, let's see. Hopefully this takes less than 15 minutes. Okay. So that's the input test. I'm gonna read in a line. And we're gonna have a total sum, starts at 0. And what we want is all of the digits inside of the line, which are numbers. So it's num is digit, maybe? Is digit. Sum plus equals C. Well, actually this is kind of stupid, but I'm gonna do it like that. Oh, you can't? Okay. And we're gonna print out what we got. Supposed to get 142. Let's see if we did. Okay, well we got nothing, which is a good sign. Okay. Maybe I set up the problem wrong. Yes. Although I suspect there's going to be another problem. I haven't read this very closely, and I'm sick. In my defense. 36. Yeah, that's not it. Okay, I see now. Supposed to turn all of the digits into a number. So I'm going to start with an empty number string and add on to that. And then sum. I don't know if it's supposed to be empty or not, but just to make sure. To the sum, we're going to add the string turned into an integer of our number. I feel good about this. Okay, we got 12,000. Okay, that's also incorrect. Okay. Well, let me see what we're getting as a number. Perhaps we have something else going on. Oh, you just do the first and the last. Okay. Never mind. So it's not the whole number. It's the first one and the last one. Stop, you gotta do some weird tricks on here. How's that? Also wrong. Okay. Oh. Can't do it like this. Okay. This is going to be called digits now. We're going to add that on. And now num. It's going to be push the first thing inside of it, and then the last thing inside of digits. Yeah, this is so good. So good at this, guys. Now we got it. We have won the game, and that took a lot longer than it should have. Oh well. That's annoying. I actually, I'm not entirely sure how I'm going to do this in a nice way, so we're just going to find out. Seven, six. Okay, so we still just need the first and the last one. Okay, so I think I can keep digits, so I just have to be able to fill digits differently. Do it like this. At every point, I want to check if a number is a certain amount of head. Okay, we'll write a function for that. Bool will take a string or not bool, sorry. You know what? We'll return what number we found as a character because, I don't know, why not? And let's see, find num. That's how we're going to do this. So given a string, do that. Okay. String and an index is what I should say. Start. Well, I might not find anything, so should I say that? Or I can do something fancy like this, but it's probably not a very good idea, but you know what, we're gonna do it anyway. Never really used this type that much, but I know how it works, I think, so gonna do some experimentation. So let's start at for I equals start, I is less than, and that's actually pretty annoying. I don't think I'm gonna get this done in under 15 minutes, I'm not gonna lie. Okay. Let's think about this some more. So we can go through I'll have the index of where I am, and I'm gonna have the character itself. So I can use that index, and maybe I can do that here. So okay. So if I find a result, I can put it into digits. Hopefully it should behave the same there. So now I just need to figure this awful function out. Okay. Let's say I want to check for 1. You know, I think I'll just do is a bunch of awful if statements. That's just how we're going to do it. Okay. So that's going to check for 1, 2, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 is 5 letters, 4 is 4 letters, 6 is 3, 7 is 5, that's what's here. 8 is 5 letters, 9 is 4 letters. Okay, so I'm going to check all of the cases inside of here. Just figured out another potential way to do this. Okay, if this works, I will feel so good. You know what? So I'm going to skip the first start element, and then I'm going to take 3. And if we turn that into a string, okay, I got this. Sweet. So turn that to a string. Drop the first start element, then take 3. If that string is equal to 1 or 2 or 6. 1, 2, 6. Well, actually I should probably do it one at a time. And if it's 2, we can return 2. 6, we can return 6. Yeah, okay. You know what? Don't think I need that outer loop anymore. And we're going to do this with 3 letters and 4 as well. Take 4, then 5 will take 5. Excuse me, I'm sick. This is taking a lot longer than I wish, but you know, oh well. Four is equal to 4. 1, 2, oh, I'm missing 3. Okay. 3 is 5 letters. This is so error prone, and this is probably a bad idea, but did I just say 3? 3 there. Yeah, this is incredibly bad. 1, 2, 3, 4, 5, 6. We can do 7. 8 is 4 letters. 8 is 5 letters. 9 is 4 letters. Otherwise, just return the empty optional, indicating that we did not find anything. This might just crash. Oh, it didn't crash. Wow. Okay. That's not the correct answer. Let's see what we're getting with this. That actually might be correct. Wait, nope. I suspect. It's interesting that we're getting the test data correct, though. That's a surprise. 281, that's actually correct. Okay, so the input doesn't work for all cases. That's actually quite a terrible problem to be solving at this stage. In what instance? Oh, refresh that. What cases would that not work? I did put in that correctly, so let's see. 1, 2, 3, 4, 6, 7. Otherwise, nothing. Well, let's think. If we're at index 0, we drop 0, so we do start at the beginning. Then we want to take the next 3. Yeah. Tricky. I don't like that it works for a small test case, but doesn't work for the big one. That's very unfortunate. Well, best I can do for now is probably just see what we're getting for the front and back. Oh, that was probably bad here. Okay. 2 and 8, 6 and 6. 9 and 6. Okay, so all of these actually look correct to me. Oh, you know what? Well, they have to be matched against the input. Okay. 3 and 3. 4 and 7. 4 and 5. Yep. 9 and 6. 9, 9, 9, 6, 6. Yeah. Troubling. It only works. Doesn't work for the big test case. That's quite unfortunate. Okay. And I'm not. Excuse me. Doesn't look like I'm skipping any test cases because of that, right? So that's not actually doing anything. Just to make sure we should get the same results. Yeah, okay. I want to make sure this is definitely getting the correct answer first. Wow, it is. And this is definitely the correct input. One more time, is it really? It's not the right answer, okay. Some bad news. Okay. 6, 7, 8, 9. One. That was it. That was the problem. I knew that, okay, I should have done this a different way, and that just cost me quite a few amount of mail. Wow, it's 12:20. I almost guarantee this is correct. I did it. I did it. That was so easy, guys. Join me for the next one. That was incredibly easy. Oh, wait, actually, okay. Well, I don't feel as stupid. I'm only number... Oh, that's like 8,000. Yeah, that's not very good. Let's see how my group has done. Oh, well, I was first, so you know what? I feel less bad about that now, but yeah. Okay, now join me for the next one. Okay. Actually, one final portion before we go. I'm going to show some modifications I made, which makes this run about twice as fast, and maybe try to explain some of the stranger features in here. So, originally this function takes a string. That means it's going to copy the whole string, which takes linear time. But a string view takes constant time. So instead of copying every single letter inside of the string, you just copy the address, the pointer of the string itself, with a size on it. So instead of copying the whole string, it's just where it is and how big it is. It's the same trick happening here. Previously, these would also be strings, which meant that there would be a lot of redundant copying. And I also turned my searching process into a set, even though there's only 3 elements inside of it. This makes it a lot less error prone. You saw the mistake I made is that I swapped 5 for 4 here, which is a really easy mistake to do, and it's a little bit difficult to catch. So if I put them all in a set and I just ask if they contain the words that we're looking for, we can do it all in one go with a unified interface. And we can also have all the return lines in one statement because everything's so short. So everything is now less than 60 lines for part B. So what exactly is this doing? So the line, remember, is the input, and dropping I is as we iterate through the line, we're going to just drop out how many elements we have. So if we're at this line and we want to drop 5 elements, dropping 5 will turn to an equivalent string of that. But what it's going to do is, because this is part of the views library, this is really the whole name of it, views drop, it's not going to copy the string, it's going to do the same trick as string view, which is it's going to give it the beginning and an associated range. So that's how it's able to achieve double performance. The original one that copies all the strings takes almost a second, 0.8 seconds or so, and this one takes less than a third of a second, so that's more than a double fold speed up. This is the version I'm going to have on my GitHub page.